in my last session, we were talking about features of C#.NET. One among them was platform independent. And I covered three architectures here. First one was architecture of platform independent. And second was architecture of code compilation and execution process. And third was what is called reverse engineering in .NET. Yeah, three architectures. Today we'll discuss remaining features. And in that, what we learned for the first point is here, I said language independent. And how do you describe this? See, simple conclusion that I would have here is .NET application logic can be developed in any .NET framework compatible language. Yes. So not necessary that you have to develop your program only using C#.NET. You can develop a .NET application logic in what? Any .NET framework compatible logic. And in that, you can say like this. Yeah, I would just say here. Hence, .NET is called language independent. And another interesting thing here is today, approximate of 60 plus languages supports .NET framework. Yes. How many? 60 plus languages we have today. And in that 60 plus languages provided by Microsoft. What are they? VB.NET, C#.NET, VC++.NET, F#.NET. These are the language provided by Microsoft. And remaining all are third-party languages. Yeah. And in these third-party languages, we have a very big list. And don't forget, these all are supporting .NET framework. Okay. What are they? Perl.NET. Then we have Python.NET. Then Pascal.NET. APL.NET. Then COBOL.NET. Eiffel.NET. Haskell.NET. Oberon.NET. And Smalltalk.NET. Then PHP.NET. JSharp.NET, etc. These all are third-party languages. Yeah, depends which language you're familiar with. That language you can opt for writing a .NET application program. Not necessary that everyone should write a program only using what? C#.NET. So if you're familiar with COBOL.NET, you can write a program in COBOL.NET. And that is being supported by whom? .NET framework. That is language independent. Okay. And one more important thing, what you learn is about language interoperability. What is language interoperability? Here, there what I said, .NET application logic can be developed in any .NET framework compatible language. That is definition of language independent. Now what I'm saying for language interoperability, it is a concept of developing .NET application with the help of more than one .NET language. Yes. It means this may be a requirement. Like, for example, assume that a company has some 10 C# developers working in the company. And in the same company, assume we have around 5 VB.NET developers. Yeah. Some developers are aware of C# and some developers are aware of VB. Some are related to C# and some are related with the VB. Now question is, question is, people who are aware of C#, however they are in the project, right? But the people who are aware of VB.NET manage the project. We want to include them also into what project? So it means now your project want to be developed using C# and VB both. Yeah, it would be like this. It may be some code, some programs we write in C#, some programs we write in VB. Example I'll give you so that you can understand easily. Example. This is for comparison, I'm saying. Data types. Every programming language will have data types. Okay. Integer, float, string, character, double. Data types, I'm saying. Even C language may be used to have, C++ may. Every language will have data types. But interesting thing is, data types used in C#.NET differs with the data types used in VB.NET. Yes. It means what? Data types of C#.NET are not same as data types of what? VB.NET. They are different. They are different. Now, question is, now if data types are different, then how this you can link them, like how C# you make VB understand and how you make VB code to understand with C#. Okay, now you see here. Hence, when applications of these languages need to be executed together, then the problem will be solved using one special concept that is called CTS. What do you call it as? CTS. That's referred to as Common Type System. CTS. What CTS will do? Yeah, here I can say it contains list of special data types. Special data types that are common for for both languages, through which who will understand? CLR understands. Yeah. Last time I'll discuss CTS related point. This is an example I was saying. Say, for example, VB language, one developer knows. Okay. Say, for example, this is a language which I know. Say, I know this. VB.NET, I know. And another programmer has knowledge of C# language. Yeah. This is, say, for example, this language is known to Suraj. So what I'll do? So Suraj has written one program. So let's assume like this. So myself have written one program. Yeah. Program. And similarly, Suraj has written a program in C#. Obvious, they are connected program, like some program I've written in VB and some program I have written in Suraj has written a program in C#. Okay. Now, first, let me explain you. In this program, I have a data type to use in a program called integer. I used in VB.NET. I have written a program, and in that I have used one data type related with integer, And that data type is, I'll write actual data type, integer. VB may you write integer like this. And Suraj has come across to have similar type of code. And in his program, he want to use integer. And C# may you represent integer like this. Like this. Hmm. Now story is like this. Like this. What? You want to run what? C#. Yeah. Yes. What do you want to do? You want to run now. Yeah. Yeah. What do you want to run? Yes, you want to run C# code. Yeah. What do you want to do? You want to run VB code from C# and C# code from VB. But question is, if I give this integer to C#, C# will not understand what is integer. And when I give int to VB, VB cannot understand what is int. So in order to make them neutral, Microsoft has introduced special data type that is called system.int32. One special data type. Yeah. Who introduced this? Microsoft has introduced one special data type. What is the name of the data type? System.int32. And this special data type is what you call CTS, Common Type System. And where is CTS? Where is this CTS? This CTS is a part of, I'll write here, CLR. It means CTS is a part of a CLR. Now it goes like this. Integer will get connect with int32. So now int32 will make a understand about integer to int. So here it's like this. Integer you give to system.int32 and system.int32 explains to int that it is an integer type which VB has provided. Same story. Now int VB cannot understand. So you give int to int32 and int32 will make integer understand about int. So that CTS is common type system. For both of them, it is common type system. And this CTS will allow C# to invoke VB code and VB to invoke C# code. Yes. So you can say like this. This will allow C# to invoke VB code and vice versa. Hence, language interoperable. Interoperability has become possible in .NET. Yes. C# will invoke VB code and VB will invoke C# code. That is how they are connected. C# to invoke VB code and vice versa. And I gave example. This is just an example. When we come up with practicals, when we are into coding part, on that I'll give you all the CTS which Microsoft has provided for a support of this language interoperability. Common type system, complete. For every data type, we have one common type system. The reason behind providing, now we don't know what is exactly the meaning of system. We don't know what is, this you can understand. Int 32. 32 in the sense 32 bits it is. Okay. 32 bits. 1 byte, 8 bits. 4 bytes into 8 bits. Okay. 4 8s are 32. 32 bits it is. Into 32. So how they resolve this language interoperability process with a support of CTS. Depending on what data types you are using in the program, yes, that CLR will link with CTS, and CTS makes program neutral. In that way, C# code VB can run, VB code C# can run. That possibility you have. C# coding can be executed by VB, and VB coding can be executed by C#. In that way, language interoperability has become possible in .NET. Yeah. Anything else you want to ask in this? You can go ahead. Any question you have on it?
No questions.
Okay, clear, comfortable.
Clear.
Right. Ahmed, what about you? Gaikwad, Suraj. Okay. Yeah, Gaikwad, any queries? Suraj.
No queries.
You're clear with what I said now? Right. Mm. So I said, in what way this is benefited for us, language interoperability. There's a reason I gave example like this. I said, you may have few people in the company who is aware of C#, and you may have some people who is aware of VB. It means C# people will not have knowledge of VB, and VB people will not have language of C#. They are good in their respective languages to which they are aware of. So the point is now, but even then, what company want to do? Company wants project to be completed fast. Instead of making programs develop only in C#.NET, company wants to develop programs in C# and VB both. Some programs in C#, some programs in VB. And however, we have a facility that C# code can execute VB code, and VB code can execute C# code because of this CTS available, special data types available. And who takes care of that? No, CLR. Why CLR? Because CLR is the one who executes your code. And where is CTS? It is a part of CLR. Last class mein, we talk about JIT compiler, which is a part of CLR. Today, I'm saying that CLR contains one more part that is called CTS. Yeah. And remaining features, whatever I write now, here, fourth one. Supports all OOPS concepts. Yeah. C#.NET supports what? All OOPS concepts. Yeah. Even I'm going to discuss a lot of new features which Microsoft has introduced in different versions of C#.NET. Those things also we will highlight. Yeah. C#9 may what they introduced, C#8 may what they introduced, C#10 what they introduced, C#11, C#12. But I won't discuss all those features at this stage. Even if I write, we may not be in a position to justify those points. It's only that we have to make theoretical. These are general features I'm writing. Those are version-wise features. So we are going to study them based on topic. So whenever I come across with a topic, immediately I'll say, in this version, this topic is modified in this way. So that it will be easy for you to correlate and understand how those features are converted, how those features are enhanced. Yeah, in that way I'll explain. Okay. And one more interesting thing that I would say here, supports to work with database programming that is called ADO.NET. Yes, this is one of the most important topics that you would find will be available for our C#.NET. And whatever we learn in ADO.NET, especially I made ADO.NET available with 3 modules in it. ADO.NET I made available with how many? Three modules. And what are they? One is called ADO.NET. It is called connected model. Yeah. Then we learn ADO.NET Then we learn disconnected model. And then we learn ADO.NET. We learn entity framework, that is called EDM, that is called entity data model. Yes. And before to this entity framework, we used to have one more also, that is called link programming. We'll discuss this also. Yeah, link programming, language integrated query, we call that. We can rather call like this. ADO.NET entity framework is an extension of link. Link. This is a difference. Link used to work only with SQL Server. With SQL Server. Whereas ADO.NET entity framework, which is called EDM, entity data model, it is going to work with multiple databases. In that way, it is benefited for us. And here we'll spend more time with lot of scenarios to cover on this. And whenever this is done, but you can say like this, C#.NET around 90% content is overall. 90% content. Yeah, maximum entity framework. Yeah, even I'm going to show you in .NET Core Entity Framework only. ADO.NET connected, disconnected model only in terms of C# we will do. C#. Okay, Ahmed? And total implementation in .NET Core, even here we'll focus on ADO.NET Entity Framework. And one more point, remember, especially when you want to work with this ADO.NET Entity Framework, you should be very much clear on a working of one topic called lambda expression. Because even in .NET Core, the moment you enter into programming, we come across lambda expression. And total .NET Core deals on that. Total, I'm saying total .NET Core depends on lambda expressions. So oops, whenever I cover lambda expressions, you have to more concentrate, you have to more practice, you have to go through the topic again and again, so that coming classes, whenever I write lambda expression, immediately you should correlate. Oh, that is what it is doing. This is how it is managing. This is how it is using, programming. This is how it is supporting coding. You should correlate, because lambda expression support inline coding process, inline coding, inline method, inline function, you can call. This is inline coding, lambda expressions. And for lambda expressions, Microsoft introduced one special operator. The operator will be like this: equal to, greater than symbol. That is one special operator Microsoft introduced to deal with lambda expression. This operator is called goes to operator. It's called goes to operator, it is called. So we write a coding process only with what? Okay, I'll just show you for your knowledge, because in one of my batches, I said I'm going on with .NET Core now. So in that .NET Core, I don't know whether I've rewritten or module. Here, web application. Yeah, you can find the code gets opened, and you can see here. If I run, this is web application also. I'll get the output as hello. But how did you write this code? Lambda expression. Here. Can you see here when I put my cursor? Here. Lambda expression. What is the operator called? Goes to. That operator is called goes to operator. Yeah. Lambda expression. Here. Run the code, you'll get output. Direct output. I mean, I'm just showing you. I'm not explaining anything about it. Yeah. Hello world browser mein, you can find output is produced. And background mein, one server is activated. Here, activated. This server is called Kestrel server. It is called. So a .NET Core by default uses what? Kestrel server. Yeah, by default uses Kestrel server. Yeah. How do you know that it is a Kestrel? That when we start the topic, at that time we'll discuss. So anyways, I just have come up with, I'll show you here. Refresh, and you can see here. Yes. Kestrel. Here, Kestrel server. server, Kestrel server. I'll explain. At that time, I'll explain. Two types of servers we'll have. We have something called reverse proxies. .NET Core may I'll cover that. I said na ASP.NET Core, ASP.NET Core, right? MVC, ASP.NET Core, Web API. These are the three most important modules that itself has made my content divided into 15 modules or 16 modules. These all content. I have divided into 15 to 16 modules I have covered. Yeah. But anyways, that is not a target now. It's simple to understand. I just have highlighted it. Yeah. But we'll spend time on that. I won't say that, all companies are developing the projects only using .NET. No, there are even still companies, around 60% of companies are there who are working with this model still. ADO.NET connected, ADO.NET disconnected, ADO.NET entity framework. That is the reason all three we are going to cover. All three. Sixth feature that is called, and here, one more point. Exactly when you start this ADO.NET, na? So here you will be in interaction with two softwares. One will be your this one, what do you call .NET, and another will be SQL Server. SQL Server. Indirectly, here you talk about two-tier architecture. What do you call this as? Two-tier architecture. This is also called two-layered architecture. Two-layered architecture. In what way? Now, for us, it's not two-tier architecture. It is for us two-layered architecture for us, because in the same machine I have this software called SQL Server. In the same machine I have a software called .NET software. Both are in the same machine, but in IT companies where .NET is being used, they have SQL Server or database software in one machine and .NET software in another machine. Then you're working with two-tier architecture. Yeah. Okay, but we'll spend more time on ADO.NET Entity Framework because it will be very much helpful for us, and things go very simple when it comes to your what do you call .NET Core as well. It will become very easy for us. Yes, just 1 second. Yeah. Huh? Here we learn how many things I said, like you have here ADO.NET. We are going to describe in how many ways? Two ways. Two-tier architecture, or you can call it as two-layered architecture. Okay. And one more thing. For us, what is available? Obviously, it is two-layered. For us, what doesn't work? Two-tier architecture will not work. Two-tier architecture will not work. Okay. And coming to another important thing that you would find is here supports to develop background processes with the help of Windows services. Seventh, supports to develop three-tier architecture. Three-tier architecture with the help of distributed programming. Then we have something to learn about supports to work with multi-threading. And then we learn supports to work with WPF, Windows Presentation Foundation. And then we learn supports to develop various types of applications. These all are features which basically at this stage we cannot elaborate them. Coming classes will understand them in detail. These are some of the features. Now, as I said, version-wise features, we will study topic-wise. Okay. C#9, what they introduced, how are we going to use them? 11, what they introduced, how are we going to use them? Those things I'll discuss. Okay. Now, one more important thing that I would highlight here now, especially about CLR. What is it? Common Language Runtime. That is CLR. Yes. I said, remember two things. Two things. What it is? For every language, compiler will be different, no doubt. But CLR is common. Yeah. CLR will be common. And this related with .NET software, you always notice that we are provided with two types of kits with .NET software. Two types of kits: development kit, deployment kit. Two things. So now what is CLR? How you define CLR? You can say like this. It is responsible for managing .NET code, that is CIL code. CLR related files are copied into C drive, Windows, System 32 folder. This is the location where CLR software is available. CLR software is available here, in this location. And how you work on this? Yeah, I'll explain you here. Working of CLR. Yeah, I just cover it through .png file. Already in one of the batches, I covered it. I just want to show you that how it is working. Yeah, open paintbrush. File, open. .NET 9 PM. It is reverse engineering dot C sharp binary and a collection. Yeah, no. This is about assembly we have. Anyways, it's not there. I'll draw it. Okay, so let's talk two things here. First, Microsoft made available with languages. Yeah, and that languages are in our reference to understand this C sharp and VB. Okay, yeah, two things I'll highlight. One is C sharp, one is VB. C sharp.net, VB. Yeah, two things. Yeah, talking about CLR. Okay. Now what happens? C sharp.net may you have written a program. Okay. And same thing you have for VB.net as well. Yeah, you have written a program in VB. Okay. And I'll just say C sharp related program na .cs extension. This is .vb extension. Okay. These are programs. .cs extension and this is .vb extension. Okay. This program you give to, yes, respective compilers, C sharp compiler and VB compiler. You got their own, I mean, every language has got its own compiler. Yeah, here I call language compiler. Okay. Here, programs are handed over to language compilers. And what language compiler will do? Language compilers will generate something called assembly. Yes, assembly. Yeah, C sharp will generate assembly. VB also generates assembly. What it is? It is .exe or .dll. .exe or .dll. Yes. Yeah. Assembly. Okay. And now you want to run this now. You want to run this. So to run this, what you have to do? You won't have separate softwares for them. This assembly and this assembly has to be given to one common software to run them, to run these two programs, which are developed in respective languages. We are provided by one common software that is called CLR. Yes, CLR. Do we have compilers separate? Yes, C sharp compiler is different. VB compiler is different. But what is common to run them? CLR is common. Yes. Means once this assembly is given to CLR or this assembly can also be given to CLR. We don't have multiple CLRs. We got one CLR that will run your C sharp code, VB code, ASP code, VC++ code, F sharp code, all languages code CLR will run. That is how you find a working of what? CLR. Working of CLR. Common language runtime. Yes. Anything else you want to ask on this? You can. Yes.
Okay, clear.
Clear now? Right. Let me save this also for your reference as working CLR. Yes. And now, going forward on this, what you study in the second part of this architecture is, remember, along with the CLR, something important that you have to remember, right? That is its components. It's a components. Few we already know, components of CLR. How many I said? Approximate of, right? Around 12, 11 to 12 components you will have. 11 to 12 components. Approximate of 11 components. One component which we already discussed, that is JIT compiler, just in time. Second, you call CTS, common type system. Second component. And remaining components, now we will study AMM, automatic memory management. Fourth, you call GC, garbage collector. Fifth, we call as SM, security manager. Sixth is called EM, exception management. Seventh is what you call as CL, that is called class loader. Like this, we got around 11 to 12 components available. Yeah. These are the components. And what are the advantages that you find? Advantages of CLR. One, you can say, one, you are provided with integration of code. Integration of code written in various languages. Various languages. That's what we have now. C# code VB can run. VB code C# can run. C# VB code VC++ can run. VC++ C# code VB.NET can run. Or all these code F# can run. I said no. Or this C# VB code ASP.NET can run. Yeah, you have that facility. That's what I'm meaning. Integration of code written in various languages. Yeah, you can integrate C# code in VB, VB code in C#. And you have another important code reusability. We have code reusability through something called implementation inheritance. When I start the topic inheritance on that day, you'll understand what actually this is related to. Practical, I'll show you what it means. And we have another important thing that is called automatic object lifetime management. Automatic lifetime management. Yeah. And you know, one important thing here, especially this AMM, automatic memory management, and garbage, both I'll cover. You know, in old programming languages, you know, when we used to work with C, C++, when we used to work with C and C++, memory allocation and memory deallocation, both were in our control. Both were in our control. Memory allocation process, memory deallocation process, both were in our control. How much memory you want to create, we used to say. And after completion of the task, whether memory should be there or memory should be removed. That also we only used to decide deallocation part. Both were in our control, and at that time we could not manage neither memory allocation nor memory deallocation. Both were not in our control properly. We could not handle them. So from then, what the all advanced programming languages like Java, C#.NET, VB.NET, Python, all programming languages, advanced programming languages, what they did, they took away that facility from us. Yeah, they took away. Hmm. Now you are not involved neither in memory allocation nor in memory deallocation. In both the cases, you are not involved. In both the cases, you are not involved. Memory allocation is also not in your control. Memory deallocation. You just have to say like you want to store this data. .NET software will take care of that. How much memory, where to allocate, where to store data, and to what extent, how much time it should put the data in the memory. And after once it finds that memory allocated data stored, but from long time we are not using, immediately it will deallocate that memory. All the things are automatic. You are not involved in it. That is what we have something to study about, a feature called automatic memory management, AMM. Who will manage? CLR manages memory for managed code that targets CLR. Yeah. All memory allocations of objects and buffers are made from a managed heap. And I'm going to explain all types of memories. Usually we discuss three types of memories. One is called stack memory. One is called heap memory, HEAP, heap memory. And one is called global memory. That's also called by name static pool. Once we are into programming, I'll talk on them. Yeah. All three types of memories. Programming will cover. And one more. Unused objects and buffers are cleaned up automatically through whom? Garbage collector. Yes, unused objects and buffers, both I'm saying, they are cleaned up automatically through whom? Garbage collector. Yeah. So that is garbage collector is also one topic we have. There we'll discuss how it is going to. But actually, we just see how and what methods garbage collector provide. Practically, we are not going to show, we cannot demonstrate how it is going to deallocate memory, because that is what I'm saying. It's automatic process. Okay. Yeah. That's it. And tomorrow we have one small topic to study. Tomorrow I'll explain. Small topic is there. That is called base class libraries, or it's also called framework class libraries. That's referred as BCL, FCL. Yeah, one small topic. After this, tomorrow, if time permits, tomorrow itself, I'll start even practicals on C#.NET. Okay, but before to it, I have to explain you about the tool. The tool is called what? Visual Studio. Okay, tomorrow's class, I'll explain. Is still